All right, guys. Well, let's look at these subtraction problems today. And we're going to look at a couple on the front page here. We'll look at a couple examples of like you were just shown in the video and make sure you understand it. And then we're just going to use the standard algorithm, which we're just going to subtract like you've learned to subtract in the past to find the answer. So this first problem, when it's written across horizontally like this, like it's probably going to be on your assignment today, you know you need to write them vertically. You need to write the bigger number on top, 7,525, and you're subtracting from that 3,502 to get our answer. Okay, so we'll do that in a minute, but let's just review what you just saw in the video. So this is our whole number using a tape diagram here. This is the whole number. This is how much we have in whole, 7,525. And in a tape diagram, it's represented by this number we're taking away. And what we're trying to find is this number plus this number. If we add these two together, we would get that. But since we don't know this number, we're taking this number away from this to find this variable. That A is called a variable. And we're going to find out what should go in this box to equal 7,225. This is just like one piece of 7,525. What's the other piece? If these were two puzzle pieces, what does the other piece look like that would add up to that? So we find it by subtracting. So let's look at this problem here. It's a pretty simple one. We don't have to do any regrouping in this one. We've got 5 minus 2 is 3. Remember, we start over here on the one in the ones place on the right side. 2 minus 0 is 2. 5 minus 5 is 0. And 7 minus 3 is 4. So our answer is 4,023. And what that means over here on our tape diagram is the other piece of the puzzle would be 4,023. If you have put these two together, 3,502, 4,023, if you add those two together, you're going to get the whole number right there, 7,525. So we found that missing piece by subtracting. Let's do the same thing on letter B here. So we've got a bigger number. Our whole number that we have, the big number, is 17,000. Excuse me, I sneeze every day during math. 17,525. And we know that one piece of it is 13,502. What's the other piece that's missing to get that? So this plus what is this? We find it by subtracting. 17,525. Remember, write this bigger number on top. Minus 13,502. And we're ready to subtract. It's a simple problem again with no regrouping. 5 minus 2 is 3. 2 minus 0 is 2. 5 minus 5 is 0. 7 minus 3 is 4. 1 minus 1 is nothing. 0. So our answer is 4,023 on number or letter B there. That means this missing piece of the puzzle, I'm going to write it above it this time because I don't want to get too messy down here, is 4,023. So if we had 13,502 and added 4,023 to it, we would get this whole number of 17,525. That's thinking about it in terms of a tape diagram. You may see it like this in the future with a blank here, and it wants you to know how to find that. Well, you know you can just subtract these two. Let's look at it the other way we saw in the video using our place value chart. And so I put these down here because we've got a couple of problems where we're going to have to do some regrouping. And so remember, this would take forever to try to do every single subtraction problem like this. There's just no way in the world that we would have time to draw a place value chart, and it would just take too long. But the idea is being able to know in your head what you're doing when you're regrouping. So we've got our whole number, 6,000, our big number, 6,625 represented here. I've got 6,000s, I've got 600s, I've got 2 10s, and I've got 5 1s. Now we're taking away from that 4,417. So let's start in the ones place. Can I take 7 ones away from if I only have 5 ones? I can't, can I? Because 7 is bigger than 5. I can't take 7 away when I don't have at least 7. So remember what we can do. We can regroup. We can break apart. The big word used in math is decompose. It just means we're going to borrow one of these 10s and put it over here in the 1s. So how many 1s is 110? There's 10 1s, right? So we can mark this guy out, and we're going to move him over here. We're going to decompose him. We're going to break him apart, and we're going to give ourselves 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1s. That means we only have 1 10 left because we got rid of that guy and put him over here. All right? So now we need to represent that over here. So now we've got rid of one of those ones, one of the 10s. So now we only have 1 right there. But we've changed this number on top here, haven't we? We had 5, but we've added 10 more, haven't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now we have 15 1s and 1 10. So you see what we did? Can we take 7 away from 15 now? Sure we can. 15 is more than 7. So hopefully you know what 15 minus 7 is. But if not, you could take them away. You could go, I'm going to take 7 away. 1, 2, 3, 4, 5, 6, 7. How many are left? 1, 2, 3, 4, 5, 6, 7, 8. 15 minus 7 is 8. Okay, I have 1 10, but I'm taking that 1 10 away. 1 minus 1 is 0. I have 6 hundreds, but I'm supposed to take 4 away. So 1, 2, 3, 4. There's only 1 2 left. 6 minus 4 is 2. I have 6 thousands, and I'm taking away 4 of them. 1, 2, 3, 4. There's only 2 thousands left. So there's our answer. The answer then is 2,208. That's just a subtraction problem represented on the number line. Like I said, you wouldn't want to draw that every time. It's a strategy you could use. This is a strategy you could use the tape too, but if you just can subtract it, great. This is just to make sure you know what is being done when you're borrowing from a higher place value. So let's do this one as well. We're going to use the place value chart on this one. And our larger number is 4,625. Also, when you rewrite these, make sure you put the right number and don't mix up the 2 and the 6. And we're subtracting 435. Okay. So I've represented 4,625 in our place value chart with 4 thousands, 600s, 2 10s, and 5 1s. Now, I'm going to take away 435. So let's start over here in the 1s place. Can I take 5 1s away if I have 5 1s? Sure, I can. I'll just have to take them all away. So 1, 2, 3, 4, 5. I took 5 away. How many does that leave? That leaves 0 in the 1s place. Now I have 2 10s, but I'm supposed to take away 3. I can't do it, can I? Because I don't have 3. I only have 2. So this is when we're going to borrow or break one of these down. The word that's in the standard is decompose this. So we're going to take one of these hundreds and we're going to give it to the 10s place. And we know when we're going this way, if we're borrowing, how many 10s are in 100? If we had 10 10s, we would have 100. So this little 100 right here represents 10 10s. We're going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we borrowed from the hundreds place and gave it to the tens place. So let's represent that in this number up here. We borrowed one of our 600s that only left us 5. And we gave 10 to the tens place. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right there. Okay. Now can we take 3 away from 12? Sure we can, because we have 12 is more than 3. So let's take 3 of those guys away. 1, 2, 3. How many are left? 1, 2, 3, 4, 5, 6, 7, 8, 9. 12 minus 3 is 9. We have 5 hundreds left, and it says we've got to take away 4 of those. So 1, 2, 3, 4. How many hundreds are left? Only 1. 5 minus 4 is 1. And we don't have to take away any of our thousands, so that stays 4. So that makes our answer 4,190. Again, if this is confusing to you, don't worry about it. This is just a visual representation of what we're doing when we're borrowing from the place. Me and your mom and your dad, we didn't learn to do all this. We just learned to subtract. So, but nowadays, they want you to be able to see what you're doing when you borrow. So that's what these charts represent. All right, well, let's just do some with the standard algorithm. We won't do the tape chart or the place value chart. Let's just work some more of these to practice together. Okay, so bigger number goes on top. Write them vertically. 6,500 minus 470. Okay, 0 minus 0 is 0. I have 0 tens, so I can't take away a 7. So I've got to go borrow 1 of the hundreds. It leaves 4. And I'm going to give 10 to that 0. And so now I can do 10 minus 7 is 3. 4 minus 4 is 0. 6 minus nothing is still 6. So our answer is 6,030. Please remember to put your commas in the answers. Next one. 6,025 minus 3,502. Okay, 5 minus 2 is 3. 2 minus 0 is 2. If I have 0, I can't take away, if I have 0 100s, I can't take away 5 100s, so I'm going to have to borrow from the 6. It makes it 5 thousands left, and I'm going to give 10 of those. 1,000 is 10 hundreds, so we'll give 10 to that. 10 minus 5 is 5. 5 minus 3 is 2. The answer is 2,523. I'm going to go a little quick just because these are just examples, and I want to make sure we get to the word problems before you get too bored of watching me. All right, 23,640 minus 14,630. 0 minus 0 is 0. 4 minus 3 is 1. 6 minus 6 is 0. I can't take a 4 away from a 3, so I have to borrow from there. Make that a 1. We add 10. We borrow from the 10,000s place. We get 10,000s added to the 3,000s. So 10 and 3 makes that a 13. 13 minus 4 is 9. And there's our answer. 9,010. Okay. Moving on. 431,925. Getting the big problems now. Minus 204,815. Okay, subtract. 5 minus 5 is 0. 2 minus 1 is 1. 9 minus 8 is 1. I can't take 4 away from 1, so I've got to borrow from the 3. Borrowed 1 and made it a 2. That gives us 10 more thousands, so 10 more plus 1 is 11. Now 11 minus 4 is 7. 2 minus 0 is 2. 4 minus 2 is 2. Our answer is 227,110. One more standard algorithm problem, and then we'll move on. 219,925 minus 121,705. All right, let's subtract. 5 minus 5 is 0. 2 minus 0 is 2. 9 minus 7 is 2. 9 minus 1 is 8. Oh, man, I was hoping we wouldn't have to regroup any. I can't take 2 away from 1, so I'm going to have to borrow one of the 100,000s. It makes it a 1. And I'm going to add that 10, because 100,000 is 10,000. So 10 and 1 makes it 11. 11 minus 2 is 9. There's our answer. 98,220. Okay. Now we're to the word problem parts of it. Let's apply this. The question asks us, what number must be added to 13,875 to result in a sum of 25,840? Well, this is a great problem to use a tape chart. So let's take a look at our parts here. Let's draw our two boxes and our total symbol. And so the total symbol is, the total number is this. We want to have a sum of 25,884. And one of our numbers is 13,875. So we want to know 13,875 plus what would get me that. So we've got to find the difference in these two to see what should go there. That means we're going to subtract this number from this number. So put a bigger number on top, 25,884. And this is just like those first two problems I showed you, remember? Where we used the tape chart, tape diagram. So it's just like that. It's just in word form. We're trying to find what this variable is right here. So 25,884 minus 13,875. Let's subtract. Can't take 5 away from 4. We've got to borrow from the tens place. Makes it a 7. We're giving 10 more to that 4. So now we have 14. Minus 5 is 9. 7 minus 7 is 0. 8 minus 8 is 0. 5 minus 3 is 2. 2 minus 1 is 1. So the missing portion for our variable right here, the part that must be added to 13,875 to get this 25,884 is 12,009 is our answer. All right, we'll go to the last page here. Then I'll let you go try these on your own. We've got 3 more to do. Okay, number 3 says, artist Michelangelo, you thought he was one of the Ninja Turtles, didn't you? He's an artist. Was born on March 6, 1475. Just a little after Mr. Taylor. Don't tell him I said that. Author Mem Fox was born on March 6, 1946. How many years after Michelangelo was born was Fox born? What? How many years after Michelangelo was born was Fox born? So what we're finding is how many years after. We're trying to find the difference in these 2 years. So 1946 and 1475. We could draw another tape diagram if we wanted to. If we set it up in the standard algorithm, it's just 1946 minus 1475. That'll tell us how many years there is between these two, won't it? But what we're trying to find is 1946. We know Michelangelo was born in 1475. How many years is there between 1475 and 1946? So we're trying to find this missing part right here. So we do it by subtracting. Let's subtract. 6 minus 5 is 1. I can't take 7 away if I only have 4. So I've got to borrow from the hundreds. Got to borrow 100, leaving 8 there, and we're adding 10 tens to 4 tens. 10 and 4 is 14 tens. 14 minus 7 is 7. 8 minus 4 is 4. So what we can find out is Mem Fox was born 471 years after Michelangelo. There's our answer. Number 4. During the month of March, 68,025 pounds of king crab were caught. This is making me crave seafood. If 15,614 pounds were caught in the first week of March, how many pounds were caught in the rest of the month? Okay. So we know in the first week of March, they caught that many pounds of crab. In all of March, they caught this many pounds of crab. So if they caught this many pounds in the first week, how many pounds were caught in the rest of the month? So again, let's set up our tape diagram here. And all together in March, they caught 68,025 pounds of crab. Let's try to figure out what we're finding here. And we know in the first week alone, they caught 15,614 pounds. How much did they catch in the rest of the month is what it's asking us. So what are we going to do? Just like we've been doing on all these, we've got to subtract this number from this to find the missing number. So let's set up our algorithm. 68,025 minus 15,614. And we just need to subtract. 5 minus 4 is 1. 2 minus 1 is 1. Can't take 6 away from 0, can I? So I'm going to have to borrow from the thousands place. Instead of 8 thousands, we're only going to have 7 thousands because I gave 10 to the hundreds place. We had 0, so we becomes a 10. 10 minus 6 is 4. 7 minus 5 is 2. 6 minus 1 is 5. So from the total number of the pounds of crab they caught in the month, they caught this much in the first week. Then after the first week, for the rest of the month, they caught that much, 52,411. So that is our answer. Okay, one more. These aren't so bad, are they? Just have to think what it's asking. The last one says James bought a used car. After driving exactly 9,050 miles, the odometer read 18,064 miles. 118,064 miles. What was the odometer reading when James bought the car? Okay, let's set up our tape diagram. All right, so the odometer is reading right now 118,064 miles. Now, since James has bought the car, he has driven it 9,050 miles. Okay. So what we want to know is, before he drove those 9,050 miles, what was the reading on the car's odometer that tells how many miles the car has gone? We know the total number now is 118,064. He's only driven this many, so how many miles were on the car when he bought it? So it's this number. It's our variable. So just like before, we're going to subtract these numbers. 118,064. We're going to take away the number of miles he drove, 9,050. And let's subtract. 4 minus 0 is 4. 6 minus 5 is 1. 0 minus 0 is 0. I can't take 9 away from 8, so I've got to borrow from the 10,000s place. Borrow 1 from 1, leaves 0. Gives me 10 extra thousands. 10 plus 8 is 18. 18 minus 9 is 9. 0 minus 0 is 0. 1 minus 0 is 1. So our missing number is 109,014. So when he bought the car, it already had 109,014 miles on it. Okay, guys. So you've learned some new ways to think about subtraction today with our tape diagrams and being able to model it on the place value chart. Now, like he said earlier in the lesson, as long as you can do it correctly and find the right answer, then do it. If you need to use a tape chart, do it. If you need to use the place value chart, then do it. If you just want to subtract, then do it. Okay? Read your questions carefully and go give it a shot. I'm anxious to see how you do.